Okay, let's go over another set of problems that you're going to probably see on the AP exam that deals with what I call the F prime and F double prime problems. And usually what you're going to be doing is you're going to be given the F prime and you have to tell something about the original function, or you're given something in F double prime and you have to tell something about the original, or about the first derivative and the original function. So, as we recall, way back from chapter 3, if we have f prime, and we're going to have a critical point, and I'll say critical point 1 there and critical point 2 here, and I'll explain what those are in just a second. And let's say you take a number and you put it in the original, into the derivative, and it becomes a positive here. And you take a number in between here and here, and you take it and plug it in the derivative, and it becomes negative, and a number here, and it becomes positive. What this is going to tell us is this is going to tell us about our original function. What this says is f is going to be increasing here, and f is going to be decreasing here, and f is going to be increasing here. So we have increasing, and then we have decreasing, and we have increasing. So what this is going to tell us is that this critical point, we're going to have what we call a local max value of f at this first critical point. And we're going to have a local, well, let's just go ahead and put it this way. F has a local min at this critical point 2 here. So usually what is going to happen, the problems aren't going to be concrete. They're not going to give you a function and they're going to say, hey, take the derivative. Well, sometimes they will. On the multiple choice part they might. They're not going to give you original function and said take the derivative and just do a concrete problem, just brute force the problem. What they're going to want to do is they're going to kind of want you to think about it a little bit and make the connection between the first derivative and the original function. And most of the times what they're going to do is they're going to have a graph of f prime, and they're going to ask you questions about f and f double prime. Now there's one more thing that we have to do here. The other thing that we have to do here is look at our second derivative. So if we look at our second derivative, that's going to be the derivative of this thing, and once I do an example, and that's going to be in the next video, we'll show you how we make the connection there. And let's say we have a critical point 3 here, and let's say we take a number that's in between negative infinity and this critical point 3 and plug it into the second derivative, and it becomes positive. That means f is concave up here. So f concave up. And if it's negative on this side, f is going to be concave down. F concave down. And so what this tells us, that where it changes concavity, we can say f has an inflection point at this critical point. And I know it's kind of hard to understand and see it for the first time, or maybe even the second time. For me it was the third time, but anyway. Finding these critical points, and let me go ahead and define what these are. This critical point 1 here and critical point 2 is where f prime of x is equal to 0 or f prime of x does not exist. That's going to get us our critical points. For this critical point here, this is again just exactly like this, but instead of dealing with first derivative, we have the second derivative. So f double prime of x is equal to 0, or f double prime of x does not exist. All right. Now, a couple other things about these f prime and f double prime problems is you're going to have to probably know the first and second fundamental theorem of calculus. And the second fundamental theorem of calculus is if you integrate from a to x of f of t dt, and we'll call this g of x. If you take the derivative of this, g prime of x, that what you do to one side, do to the other side. So if we take the derivative of this side of f of t dt, what this is going to tell us is you just take this x and plug it in for wherever we see a t, and we're going to have just f of x. So g prime of x is equal to f of x. Now the first fundamental theorem of calculus, and some books swap them. Some say this is the first fundamental, and then we'll look at the second fundamental. But it really doesn't matter, which you just have to say by the fundamental theorem of calculus if it comes up. And here's what the second fundamental theorem of calculus says. It says if you integrate from a to b of f prime of x dx, that's equivalent to saying f of b minus f of a. Or, I've also seen it this time if you say the integral from a to b of f double prime of x dx is equal to f prime of b minus f prime of a. Now let's look at this fundamental theorem of calculus, and there's a couple applications, and here's some real quick examples for us. And let's say we want to integrate from a to b of f of x dx, and let's say we have a function that looks like this. Let's say it does this, and we have this and this, and here's our a, and here's our b, and let's say this area underneath here is 15, this area is 8, and this area is, oh, I don't know, 7. And if we say we want to integrate from a to b of f of x dx, what that's going to do is you're going to take the stuff above the x-axis and subtract the stuff below the x-axis. So we're going to have 15 minus 8 plus 7. And you'll come up with 14, I believe. So that'll be 14. Now that's one way to look at it. Another way to look at it is if you have a table, and if you have a table, and let's say you have, maybe I can fit it right here. Let's say you have, this is x, and this is f of x, and this is, oh, I don't know, 2, 5, 9, and let's say 15, and you have negative 3, 4, 7, and 12. And I want to do this. I want to say the integral from 2 to 9 of f of x dx, or f prime of x dx. If I apply this thing to it, it's going to be f of 9 minus f of 2, and f of 9 is 7 minus f of 2 is negative 3, and we come up with the value of 10. So knowing this thing right here, all of this and this, we're ready to do battle with an f prime, and f double prime problem, and that's going to be on the next video. All right?